These are the Mod 4.5 notes, page 2. So example 2 here, we want to compare the standard deviations of the graphs below. Notice that I tell you what the standard deviations are. The standard deviation at University A is 16.2. Again, we're talking about IQ scores. So take a look at the data that we have for University A. That data is spread out more. Okay, down in the 55 to 70 range, up to the 130 to 145. The average distance from our mean of 100 is that 16.2. University B, standard deviation is 8.1, and take a look at how spread out that data is. Here now, we've got data spread between 85 and 130. So it's a smaller range than University A, okay? Not as inclusive. So here's what this means. University A has IQ scores that are more spread out. So more inclusive. Uni B has IQ scores that are closer together. And so more specific or selective? Okay. Example 3, we own a pizza place and we have 2 delivery drivers, Amanda and Bethany. Both drivers have that mean, that average delivery time of 20 minutes. Amanda's standard deviation is 3 minutes and Bethany's standard deviation is 7 minutes. This one's a little brutal. Which delivery driver would you keep and which one would you fire? So we are going to keep Amanda because she's more consistent. Bottom line, if I tell my customers that they can expect their delivery to be there in 20 minutes, she is going to be closer to hitting that 20-minute mark. Consistent. Ooh, I apologize if there's a typo there. Consistent. I don't know. I will look that up later. Okay. Variance we don't use as much as standard deviation. Sometimes we do talk about it. Our sample variance. Variance is the square of the standard deviation. So actually, it's what we find before we take the square root. So S squared for sample. It's a funky looking S, looks more like a. And for the population, it is sigma squared. So to find our standard deviations from example 2, so for Uni A, my standard deviation was 16.2. So to find my variance, I'm squaring that. I get 262.44 for University B. My standard deviation was 8.1. When I square that, I get 65.61. Notice something. The standard deviation for University A is twice that of University B. My variance, though, is 4 times as large. So the larger the standard deviation, the bigger the variance is going to be. Okay.